Welcome to Eureka Math. I'm Mr. Shankel. I'm going to be helping you today with Module 4, Lesson 23. Let's get started. Okay, so lots to do here. Let's dig right in. Number 1, sketch the graph of the equation 9x plus 3y equals 18 using intercepts. Okay, so in order to do that, I'm going to make x equal to 0 in order to find the y-intercept. If I make x equal to 0, I get the equation 3y equals 18. And if I multiply both sides by 1/3, I get y equals 6. So when x is 0, y is 6. That's my first point. When x is 0, y is 6. So I can sketch that. And then I'm going to make y 0. And if I make y 0, I get this equation, 9x equals 18. And then I'm going to multiply both sides by 1/9, and 18 divided by 9 is 2. So I get x equals 2. So my new point is when y is 0, x is 2. So there's my next point. And then I can sketch that, and I'll just do that real sketchy over here, right? Real sketchy. Okay, so let's put those points on here. 0 to the right or left, 6 up. That's somewhere in there. And then 2 to the right, 0 up or down, somewhere in there. So there's my line, okay? And my line is gonna run right through both of those points, on and on forever in both directions. All right, so that's number 1. Part A, sketch the graph of the equation y equals negative 3x plus 6 on the same coordinate plane. Okay, well, on the same coordinate plane, I can do that. If I do this, that means my y-intercept is 6. That means I'm going to cross at positive 6. That's that point. And then I'm going to go, the slope is negative 3. That means down 3, right 1. Down 3, right 1 is here. Down another 3, right 1 is there. And what do I get? Well, I get the same line. So part B, what do you notice about the graphs of 9x plus 3y equals 18 and y equals negative 3x plus 6? They're the same line. So I'm just going to write in here, they are the same line. Rewrite y equals negative 3x plus 6 in standard form. Okay, we can do that. Standard form, I would need to add 3x to get that over to the left side. Add 3x. Okay, and so I get 3x plus y equals 6. 3x plus y equals 6. And identify the constants of that standard form. Okay, well, I can do that. The constants are 3, 1, and 6. 3, 1, and 6. So A is 3, B is 1, and C is 6. And then identify the constants of the equation 9x plus 3y equals 18. All right, so those are the constants 9, 3, and 18. Okay, and these are going to be A prime, B prime, and C prime. So this is A prime, this is B prime, this is C prime. Okay, and over here we have A, B, and C. All right, so now what? What do you notice about A prime over A? Well, A prime is 9. Over A, that's 3. 9 divided by 3 is 3. That's what I notice about A prime over A. What about B prime over B? Well, B prime is 3 over B. Well, that was a 1. 3 over 1 is equal to 3. Okay, interesting. What about C prime over C? Well, C prime is 18 over C. C is 6. And 18 divided by 6 is 3 again. So what do we notice? Well, I notice that the relationship between A prime and A and B prime and B and C prime and C always gives me the same constant, 3. So maybe that has something to do with both lines being the same line. Let's see. Let's explore that. Let's think about our first equation was in standard form was 3x plus y equals 6. And our second equation was 9x plus 3y equals 18. And Well, I noticed this. If I multiply all of these numbers by this 3, I'm going to get my second equation, that one, right? 3 times 3x, well, that's 9x. 3 times y, well, that's 3y. And 3 times 6, well, that's 18. So what I'm figuring out here is that I can take a linear equation in standard form and multiply it by a constant, and it's still the same line. All right, let's see if that holds up. Let's look at number 2. Y equals 1/2 x plus 3, using the y-intercept and the slope. Okay, well, I can sketch that real quick. I can put that over here quickly, and I'm going to cross at 3, so maybe there, and then that means up 1 and right 2, so it's a line something like that. So there's my line for y equals 1/2 x plus 3. Sketch the graph of 4x minus 8y equals negative 24. Well, I can do that if I find intercepts. So let's make x 0. I would get negative 8y is equal to negative 24. And negative 24 divided by negative 8 is a positive 3. So y equals 3. If x is 0, y is 3. That's my first intercept. If x is 0, y is 3. That's, let me use a different color. That's this point right here. So interesting, the y-intercepts are the same. What if I make y 0? That will give me my x-intercept. That would give me 4x is equal to negative 24, and negative 24 divided by 4 is a negative 6. So when y is 0, x is a negative 6. Okay, and so that would be 6 to the left and 0 up. Oh, that's that point. I get the same line again. So these two equations are the same line again, it looks like. Interesting. I think because of what I learned last time, I think that one equation is just a multiple of the other. One equation is a certain number of times bigger than the other, and maybe we can figure that out. So let's make y equals 1/2 x plus 3 in standard form. Y equals 1/2 x plus 3. I'm going to subtract 1/2 x from both sides, and that gives me a negative 1/2 x plus y is equal to 3. Negative 1/2 x plus y equals 3. That's my standard form for the first equation. And then let's do what we did last time and consider our constants, a, b, and c of this equation. So a is negative 1/2, b is a 1, and c is a 3. Okay, so that's that one. And then a prime is a 4, that's a prime, and then b prime is a negative 8, and then c prime, that would be a negative 24. And then we'll just compare those constants and see what happens. So a prime, I know that's a 4, over a, which is a negative 1/2. Okay, so 4 divided by a negative 1/2. That's like multiplying by a negative 2, so that I get negative 8. So that's my that's the first comparison. Let's look at b prime. That's a negative 8. Okay, let's look at b prime. Negative 8 is b prime over b, which is a 1. It's right there, and I get negative 8. Okay, that's what I was thinking was going to happen. And then let's look at c prime. C prime is a negative 24 over c, which is a 3. Negative 24 divided by 3 is a negative 8. So I get the same constant every time, and that means I could take my my negative 1/2, this equation right here, this negative 1/2 x plus y equals 3. I could take that and I could multiply through by a negative 8, and it should give me my other equation. And let's see if that's true. Negative 8 times a negative 1/2 is a positive 4x. And then a negative 8 times y is a negative 8y. And then a negative 8 times 3 is a negative 24. So yes, that's true. I just multiplied through by a constant, and that gave me an equivalent equation, kind of like an equivalent fraction. Okay, that's good. Let's check this again. This time they tell us that these two are the same line. We're going to rewrite y equals 2/3 x minus 4 in standard form, so that means subtract 2/3 x from both sides, subtract 2/3 x, and that gives me a negative 2/3 x plus y is equal to negative 4. So there's my standard form of that equation. And here we go. We're gonna check these constants again and make sure. So this is my a. That's a negative 2/3. That's a. And then this would be b. That's a 1. And then this is c. Okay. And then we'll use the other equation to find our a prime. So a prime would be that 6. B prime is that negative 1. And c prime is 36. And then we're going to check the comparisons again. Let's see what happens. I think I already know what's going to happen. They're all going to be equal to each other, but let's see. A prime is 6 over a, which is a negative 2/3. Well, that's like multiplying by the reciprocal, multiplying by a negative 3/2. So negative 18 divided by 2 is a negative 9. So that first one's a negative 9. Let's see if that holds for the rest. B prime is negative 9 over B, which is 1. So yeah, negative 9 divided by 1, that's negative 9. And then C prime, C prime is 36 over C, which is negative 4, and 36 divided by negative 4 is a negative 9. So negative 9 is my constant, and they have the same constant again, and I did notice that. And if I multiply that constant by the standard form of the first equation, this one, I should get the second equation. So if I multiply through by negative 9, I get a positive 18 divided by 3 is 6x, and that's true. And then that's negative 9 times y is a negative 9y, and that checks. And then negative 9 times negative 4 is a positive 36. So that's equal to a positive 36, and that is exactly what I had for my other equation. Okay, so knowing that, I can take any equation and just multiply by some constant and create new equations that are equivalent. So I'm gonna take this 3x plus 2y equals 7, and I'm just going to multiply by some constant, and I can choose whatever I want. I'm going to make it easy on myself. I'm going to make it a 2. So then I just say, well, 2 times 3x, well, that's 6x, and then 2 times 2y, well, that's a positive 4y, and that's equal to 2 times 7, and that's 14. So that's an equivalent equation. I just multiplied through by 2. And in order to get 2 more, well, I'm gonna keep doing the same thing. I'm gonna take this original equation, 3x plus 2y equals 7, and I'm gonna multiply by some constant. And I'm gonna do that 2 more times. So let's choose some possibilities here. We can really multiply by anything there. How about, I don't know, how about 5? Let's see what happens there. 5 times 3x, that's 15x, plus 5 times 2y, that's 10y. And that's equal to 5 times 7, that's 35. That's an equivalent equation. What if I multiply by a negative, maybe a negative 1? Can I do that? Sure. Negative 1 times 3x, well, that's a negative 3x. And a negative 1 times 2y, well, that's a negative 2y. And a negative 1 times 7, that's equal to a negative 7. That's an equivalent equation. So all I have to do is multiply all of the terms of the equation by a single constant of my choice, and I get 3 equivalent equations. All right, so let's do it again. Let's see what we can get here. X minus 9y equals 3/4, and I'm going to multiply through by something, and I'm going to make this easy on myself. I'm going to copy that and paste it down here. So I've got 3 of these that I can use. Let's see if I can paste it again. Yeah, 3 of these that I can use to create equivalent equations. All right, so I'm going to just multiply by 2. Okay, 2 times x, that gives me 2x. And then 2 times a negative 9, that's a negative 18y. And that's equal to 2 times 3/4. Well, that's 6/4 or 3/2 if I simplify. So that's an equivalent equation. I could multiply by, I don't know, let's multiply by 4 so we don't have a fraction at the end. 4 times x, that's 4x. 4 times a negative 9 is a negative 36y, and that's equal to 4 times 3 is 12. 12 divided by 4 is 3, so that's 4x minus 36y equals 3. That's a good one. And then, I don't know, let's do negative 4 because that was kind of cool to get rid of that fraction. So let's try the negative. Negative 4 times x is a negative 4x. And negative 4 times negative 9, that's a positive 36y. Oops, 36y. And that's equal to negative 4 times 3 is a negative 12. Negative 12 divided by 4 is a negative 3. So that's an equivalent equation. It's as simple as that. Okay, how about another? Yeah, why not? What else do we have to do, right? Yeah, negative 9x plus 5y is equal to negative 4. And I'm going to use that 3 times, so I'm going to copy that. I'm going to paste it right below. That's 2, and then I'm going to paste it again. And that is my 3 that I'm going to use to create 3 new equations. I'm just going to choose a constant and multiply through and see what we get. So let's multiply by 2. 2 times negative 9, that's a negative 18x. 2 times a positive 5 is a positive 10y, and that's equal to 2 times negative 4, that is a negative 8. So there's an equivalent equation. How about, I don't know, let's do negative 1, okay? Negative 1 times negative 9, that's a positive 9x. Negative 1 times a positive 5 is a negative 5y, and that's equal to a negative 1 times a negative 4 is a positive 4. That's an equivalent equation. And I don't know, let's do 10. That'll be fun. 10 times negative 9, that's a negative 90x. And 10 times a positive 5, that's a positive 50y. And 10 times a negative 4 is a negative 40. And that's an equivalent equation. Okay, this time we're going to write 2 equations in the form ax plus by equals c, whose graphs are the lines shown. So in order to do this, I'm going to need to know slope. So let's see, I've got a point here that crosses at an intersection, and here's one that also crosses at an intersection. So I know that the slope is up 1 and right 4. Up 1 and right 4. So that's 1/4. So I know the slope is 1/4. So y is equal to 1/4 times x plus whatever my y-intercept is, and I just don't know exactly what that's going to be. So I'm going to plug in one of these points, either one. I guess I'll use this one. This one's at -1, -1. So that's my point. And then I'm just going to say, y is a -1, so I'm going to plug in a -1 for y. That's equal to 1/4 times x, which is a -1, and plus b. So then I'm going to simplify so I can isolate the b. Negative 1 is equal to 1/4 times negative 1 is a negative 1/4 plus b. And then I'm going to add 1/4 to both sides. If I add 1/4 to both sides, I will get my answer for b. So the negative 1/4 and the positive 1/4 go away. I get b is equal to, well, a negative 1 and a positive 1/4. Well, I'm going to make that negative 1 into a negative 4/4. And now I have a negative 4 and a positive 1. That gives me negative 3/4. So negative 3/4 is where the line crosses the y-axis, and that looks like that's true. And now I can write the equation fully. Y, let's write it up here. Y equals, the slope is 1/4 x plus the y-intercept is a negative 3/4. And that's an equation, but I have to write it in standard form, so I've got to do some work here to change my equation so that it's in standard form. I'm going to subtract 1/4 x from both sides, and that gives me a negative 1/4 x plus y is equal to a negative 3/4. So there's my first equation. And then in order to get another equation, well, I'm just going to multiply through by some number, and I think I'll choose the number 4. 4 times a negative 1/4 is a negative 1x, so that's negative x. And then 4 times y, well, that's a positive 4y, and that's equal to 4 times negative 3, that's a negative 12 divided by 4 is a negative 3. So there's my second equation. All right, kind of putting everything together, finding the slope so we can write an equation, changing slope-intercept form into standard form, and then writing two equivalent equations. All right, again, I can't use intercepts here because they cross not on an intersection. So I'm going to use a couple of points that do cross on an intersection. That's one. That's the point 2, negative 2. And I'm going to use another point. That one looks like it crosses on an intersection. That's negative 1, positive 2. So negative 1, positive 2. And I could use my slope formula, but since I have the graph, I'm just going to count. I would have to go up 4, and then left 3. So that's a positive 4 over a negative 3. And so that's my slope. Let me write it over here. The slope is, if I wrote this equation, it would be y equals the slope, which is a negative 4/3, x plus b. And I need to solve for b. So I'm going to plug in some values for x. I guess I'll use this equation, or this point. The y value is a 2, so that's 2 equals negative 4/3 times x. Well, x is a negative 1, and then plus b. So now I can simplify. 2 is equal to negative 4/3 times the negative 1 is a positive 4/3 plus b. And then I want to isolate the b, so I'm going to subtract 4/3 from both sides. Subtract 4/3 from both sides. And what happens is I get b is equal to, well, this would be 6/3. 2 is actually 6/3. And a positive 6 and a negative 4 gives me a positive 2/3. So b is equal to 2/3. And now I can write the equation y equals negative 4/3 is my slope times x plus 2/3 is my y-intercept. And that is the equation in slope-intercept form. Next, I'm going to change this so that it becomes standard form. So I'm going to multiply. I'm going to add 4/3 to both sides. Add 4/3 and x, 4/3 x, of course, and that gives me 4/3 x plus y is equal to 2/3, and that's one possible equation. And then I can just multiply through by a constant. I think I'll multiply through by 3. 3 times 4 is 12. 12 divided by 3 is 4x. Plus 3 times y, that's 3y, is equal to 3 times 2 is 6, divided by 3 is 2. So there's another equivalent equation in standard form. All right, that is lesson 23. I hope that helps. We'll see you again next time.